Hello everyone. So let's start with part two, the interview questions. Okay. So this is the part two of my first OOPS video. So let's try to answer some of the questions along with the code explanation. Okay. So why do we need OOPS? So the first thing, why do we need OOPS? So OOPS stand for Object-Oriented Programming. Okay. So OOPS helps us to think in a term of real world object. Okay. So let's write the answer. OOPS helps us to think in terms of real world object. Okay, so OOPS helps us to think in a real world object. Let's thinking about real world object. Let's take an example of hospital. Okay, let's take an example of hospital. Let's try to code it. Yeah. So let me first do some changes. So yeah. So let's start with the code. Hash include what we include bits slash standard C++ dot h. So first of all, we are talking about hospital. So first we will take a class of doctor. Okay. So let's talking about doctor. So inside this doctor, we are taking uh, first of all we have to take the name of the doctor. So let's make a private access modifier. So in private access, we have a string as a name. Okay, I am taking a small example. So let me do some indentation. Okay, so we have a public. In public, we are taking a making a custom constructor. Okay, so if you don't know the custom constructor, you can take a brief on my part one video. So let's define my doctor. Say this doctor, I am taking a string named as S, assigning this name to my n. Okay, assigning name to n. So after this is the public. Okay, let's make the string name get name. Okay, so this will return me the name of the doctor. After this, I am making a class name as a class patient. Okay, in this patient, I am taking the private variable for the name, taking the string name of the patient. Okay, name, string, address, anything you can take. For a small example, I am taking name only. We have take public. In public, we are assigning, making again custom constructor. So let's make it patient. We are taking the string 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 for the name, and we pass our object doctor. Let me, yeah, as a pointer doctor. Okay, inside this I am assigning the my name as n, and this dot doctor as doctor, as my patient doctors. Okay, so first of all, let's get the name of my patient. That's string, return type string, get name. Inside this get name, we are returning the name of my patient. Okay, so we have a doctor. Inside this doctor, we have get doctor function, doctor. Okay, so let's return doctor. Okay, this is simple. After this, we will talk about some what we can say. Let's maintain a int main function. Let me change my arrow. Yeah. So here I am defining my main function. So let's int main return 0. So first of all, we create a object of doctor, that is doc1. Inside this doc1, I am passing my doctor's name, Dr. Ankit. Okay. As I am defining here, let me change my cursor again. Yeah. As I make the custom constructor function. So for that, I need to pass the string as a doctor name. Okay. So after this, I make a patient object as patient1, passing the name of the patient, that is, suppose what we can say, Aditya. Okay, and the doctor name is ampersand. We have to pass it as a reference. For that, we have a doctor1. Okay, so now let's try to print out the details of the patient as well as the patient's doctor. So let's patient patient's name. So we are using get function. So let's try to print it. Patient pate1 dot get name, and okay, again see out patient doctor. Let's try to print out patient doctor. Okay, patient1 dot get doctor, get doctor. So here we have to use arrow function because it is returning me the pointer. So get name. Okay, so how this will gonna work, let me explain it. So first of all, it will get to the patient get doctor. It in get doctor, it will return me a doctor. Okay, so in doctor class, there is a function called get name for the doctor. It will return me the name of the doctor. So let's try to print out. So this is getting my error. So what is this? This doctor is equal to doctor. Okay, here I am getting an error. So let's try to. Okay, yeah, I don't define the doctor. So let's make a doctor pointer, pointer doctor. UCTOR. Yeah, fine. Let's try to again run it. Let me hide it. Yeah. So yeah, it's printing me the patient name Aditya and the patient doctor name is Dr. Ankit. So we don't use any doctor pointer here. So as you can see, the patient get doctor basically the doctor related to the patient one, it's get printed. So this is the best example for the interview. Okay, it is a live practical example. So this is the best, I think. So let's talk about the next question. So next question is, what are the four pillars of OOPS? Okay, so let's try to answer this question. So four pillars of OOPS are, first one is abstraction, second one is what is polymorphism, third one is what we call inheritance, fourth one is encapsulation. If you think this video is slow, let's speed up to 1.2x or 1.5x. You can see. Okay, that's not. So in first of all, in abstraction, what we have? In abstraction, we have show only what is necessary. Show only what is necessary. Okay, so only what is necessary. Basically, the best example for this is you can say power function in C++. Okay, so in which we passes the two arguments, which is uh, the base and the what we have the power. So it will return me 4. Basically, it's hide the implementation. What is doing, I don't know. It's basically calculating me the power of that. So it's simple. Okay. So let's talk about polymorphism. Polymorphism is object act differently in different conditions. So object acts. Okay. So object acts differently under different condition. Okay. So there is two types of polymorphism, compile time and runtime. You can check me the part one video in which we I explain all the concept of popular. Here I am just giving a brief small intro for that. Inheritance is basically parent-child relationship, parent and child relationship. Okay. Now encapsulation, hiding complexity, hiding complexity. So if you forgetting, just remember for the remembrance, I am taking a method for remember. Okay, so a pipe, A for abstraction, A for abstraction, P for polymorphism, I for inheritance, and E for encapsulation. Okay, for remembering the four pillars. So let's talk about next question. What is class and object? So class is basically it is a type of a blueprint. Okay, it is a type of blueprint. Simple. Okay. So what is object now? Object is basically it is an we can say instance of a class. It is an instance of a class. Okay, simple. So if we want to use class, we need to create the instance. Okay, so here is the main point. If we want to use the class, use the class, we need to create the instance. Create the instance. Instance or object we can call instance. Okay, simple. So let's move on to the next question. What is abstraction and encapsulation? Okay. So as we talk about above, abstraction is showing only what is necessary, and encapsulation means hiding complexity. So let's see one example. So yeah, let me undo this and just delete this part. So let's try to write a small code. Okay. So taking the previous example, hospital example, we have a class, we have a patient. Okay, we have a patient. Let's just making a private as the name. Private, let's say what we can say. We can verify verify name. Here we do something. Okay, same as we can verify address of the uh, patient. Verify. Okay, so here we do something. Okay, so in public, what we can say, let's try public. In public, we describe the string as the name of the patient. Okay, as a string, we store the address. Okay, simple. Okay, so for basically, let's take one more. Let's define the name here. Okay, string name to show the example of encapsulation. Okay, so here we use for encapsulation we use basically what we can say access modifier. So for access modifier we have defined our variable inside what we can say string name under private. For to access name to set name we use void set name function. To inside this we what we can say string and okay, so simply this dot name is equal to okay, simply this is the example of an encapsulation. Okay, so let's define some one more parameter validate to validate our patient. In validate we are verifying name, verifying address, verifying name, verifying address. Okay, so this is the part of what we call uh, basically in the main abstraction. Okay, so we define a patient p1. Okay, so p1 dot name, p1 dot name is p1 dot name is equal to, we can't set here as this, pivot dot set name as Himanshu. Okay, so p1 dot verify, p1 dot verify, so verify name, validate. Okay, validate, simple. Okay, so this is how we can create an example of a encapsulation and abstraction. So here we can see we encapsulate the uh, string name and we are using a validate function as a what we can say uh, to abstract that function. I don't know if I use this class. I don't know what the validate function is do. Basically, it's verifying address and verifying name. It is similar as the what we can say power function in C++, power in C++. Okay, it is a implementation of abstraction. Okay, so this is an example of abstraction and encapsulation example. So let's try to make some points. Okay, so we can say an interview. So let's try to make some points. Okay, so first of all, what we can say encapsulation and abstraction. I'm using abbreviation. Okay, so encapsulation and abstraction. Okay, are complement to each other. Are complement to each other. Complement to each other. Okay. Second point is abstraction is basically used in the phase of when we are designing our program interface. So it is used for designing in designing phase. What has to be shown in publicly, what has to be shown as private, how the implementation is working. So it is usually in done in the design phase. So abstraction happens during design phase, during design phase. Okay, so basically this means happens means what to show, what not to show, what to show publicly. Okay, second, encapsulation. So encapsulation is used when we are in the phase of what we can say execution phase. Okay, so encapsulation happens during execution phase. Okay, execution phase when developer uses to uh, test the program. Okay, test and implement, uh, hiding the complexity of that program using public, private, and protected access modifier. Okay, so here one important thing is encapsulation implement abstraction. Okay, encapsulation implements abstraction. Okay, so this is the important point in you have to keep in mind during the interview. Okay, so let's move on. What is inheritance? So inheritance, as we can see, it is defined as the parent-child relationship. Okay, it is defined as parent-child relationship. Okay, parent and child relationship. Simple. Okay. If you want to see example, you can uh, prefer the first video. Okay. So let's talk about virtual keyword. So virtual keyword is help us to define some logic in parent class, which can be basically overridden in child class. Okay. So you can say, so let it write virtual keyword. Virtual keyword helps us to define some logic in parent class, which can be which can be overridden in child class. Okay, so let's take a small example here. Suppose I define a class. Let's me take a white pointer. So let's define a class name class A. Okay, I define here a function with the virtual keyword virtual function. Okay, class B, which is inheriting class A, class A. Okay, so here I am defining the function. Okay, with different logic. Okay, so this is the same function as we define, but it has a different logic, so we can define using virtual keyword. So that's it. You can see my video for that, for a coding example. So let's think we move on something called pure virtual function. Let's move on to pure virtual function. Okay, so let's move on to pure virtual function. What is pure virtual function? This we can say a class which is purely defined. Okay, so what does it means? Let's take an example. So for let's make a class A. How to define a pure virtual function is basically we define a virtual void show is equal to 0. This is the function name show. So this is how we define uh, define a pure virtual function. So this is, we can say, this class is known as this class. Let me, this class is known as abstract class. Okay, abstract class. Simple. This class is known as abstract class, and this function is known as abstract pure virtual function. Okay, this function is only made in base class. Okay, so keep that in mind. Base class. Okay, this is important here. So this is basically defined in the base class. So we have to take some points in the mind while creating a pure virtual function inside a abstract class. So first thing is, we can't create object of an abstract class. Okay, we can't create object of abstract class. Okay, so basically what does this mean? If I am defining a pure virtual function in abstract class, I can't create an abstract class object. Okay, simple. So it is that. So next point is, if any class inherits the abstract class, the derived class basically must define a pure virtual function. If not, then it can't be create object of the derived class. Okay, so if I am inheriting a, basically if any class, any class inherit the abstract class, the derived class must define pure virtual function. Okay, pure virtual function. So this is the important, some important points. So you have to take care in mind. Okay, and one more point is important. We can create. We can't create objects. Okay, but we can create what we can say, pointer to an abstract class. Okay, we can create pointer to abstract class. Simple. Okay, so we can create pointer, but we can't create object. So that's all about the abstract class. So why we need, there is a point, if the interviewer asks why we need the abstract class, because it is not defining anything. So abstract class is used to provide an appropriate base class from which other class is inheriting. Okay, so why? Let's answer this question. Why we need to why we need abstract class? Okay, so to provide an appropriate base class from which other class are other other class inherits. Okay, so let's move on to the next question. What is overloading? Okay, so let's see overloading what is. So basically overloading is a, we can say, method overloading means, we can say, same method name with a different signature in the same class. Okay, so let's define. It means that same method name with different signature in same class, in same class. So here we have same class and we have different signature. What does it mean? Let's take an example. If we are defining a class, suppose class A, okay. So if we define a function that is void function, suppose it does not have any signature right now, does not have parameter, do something. And if I want to define something called void function and this take a parameter int name, suppose, okay. So do something, okay, do something here, do something here. So this is an example of a overloading in which we change the signature of that function, okay, simple. So let's talk about what is overloading and what is overriding. Okay, so overloading method basically means method with the same name with different signature. Okay, this is called overloading. And in overriding, we usually use private keyword and overriding in a child class. Okay, so let's write this. Let me change method with same name with different signature in different class in same class. Here you have to take care in, let me, in same class. Okay, same class but different signature. Here we have to use in different classes. Okay, using virtual keyword, using virtual keyword. Okay, and overriding in child class, overriding in child class. Okay, simple. This is the basically difference between overloading and overriding. Let's move on to the next question. What is polymorphism? So let's see. So poly means many, okay, and morph means changes as per situation or any form, we can say changes as per situation. Okay, so this polymorphism means poly means many, morph means changes as per situation. So it is an ability of an object to act differently under different condition. Okay, so it is an ability, it is an ability of object to act differently, to act differently under different condition, under different condition. Okay, so this polymorphism means, so can polymorphism works without inheritance? We can say yep, real polymorphism cannot achieve without inheritance. So yes, partially yes, but in some cases we can achieve it. Okay, so in some cases we can achieve it. So what is static versus dynamic polymorphism? Static static is basically, we can say, compile time polymorphism, and dynamic means runtime polymorphism. Okay, so in compile time, basically static polymorphism is implemented by method of overloading. So we can say compile time polymorphism is implemented by overloading, okay, and runtime is basically implemented by method overriding, okay, implemented by method overriding. Simple. ठीक है? Okay. So compile time means check at the time of compilation. Check 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 कर लिख दिया. Check at the time of compilation. Solve for the mistakes. Okay. Check at the time of runtime. Okay. Check at the time of runtime. Okay. Simple. So let's move on. What is operator overloading? So operator overloading, basically we can say help us to redefine additional functionalities of plus minus, okay, plus minus multiply we can say. So let's write it. Operator overloading helps to redefine additionally functionality, okay, for plus minus, for plus minus and multiply, all that's basically operators, okay, simple. So if you want to see an example, you can see in my previous video, part 1 video, okay, we have described, okay, so why do we need abstract class? So I previously answered this. So basically abstract classes are half defined classes which we can use for as a base class for the other derived class, okay. So it is, we can say, half defined parent class, okay, half defined parent class or partially defined. Simple. So can we can betterly derived as a derived class, okay. Our abstract methods are virtual, so yes. Can we create an instance of an abstract class? So this is the important. So no, we can't create an instance of an abstract class because it is half or partially defined, okay. So it is important, okay, in terms of interview. So is it compulsory to implement abstract method? Yes, it is compulsory to implement because uh, as we can see above, we can't create any instance of that abstract class. So we need to define that class in a derived class so that we can basically use and make an instance of that class, derived class. Okay. So yes, so that's all I think. Yeah. So thanks for watching.